Okay, hello guys, how are you? I hope I'm just going to explain some of the problems, some of the questions about net present value taken from the book, which is obviously Financial Performance F9 in the course, which is a textbook for ACCA. And let's see what we have. We're also going to discuss another problem in terms of real and discount, real cash flows and discounted cash flows, and we're just going to also discuss about the problem as well. So first of all, with this net present value, an organization is considering a capital investment in new equipment. The estimated cash flows from year 0 to 5, that is 6 years cash flow in dollar, and which is this is the cost of capital 9%. Calculate NPV of project to assess whether it should be taken or not. So first of all, just to have, yeah, this one here. Discount factor at 9%, and this is PV. Okay, so what we're going to do, we're going to have the year 0, 1, 2, 3, 4, 5. Cash flows are this is 80,000 or 80. Then we have 120, 40 and 20. So discount factors at that would be 1. By the table it would be 0.917, 0.842, 0.772, 0.708, 0.650. So the present value would be, just multiplying this with this, that would be negative of 240. Then we have 73360, 101040, 54040, and that is 28,320, and 13,000 is this one. When you're going to have, obviously you can tell it over here, so the value would be 29,760. That would be positive NPV. So this is how, and obviously NPV is positive. Project should be undertaken. Okay, this is how you're going to say it. So this is the short solution to the numerical, which is in front of you, saying about where just to calculate the NPV of a project to assess whether it should be taken or not. And now what I'm going to have another problem, which has a project has the following cash flows before allowing for inflation, that is, they are stated at their T0 values. Timing 0, 1, 2, 3, cash flow 7, 50, 330, 242, and 532. The company's money discount rate is at 15.5%. General rate of inflation is expected to remain constant at 5%. Evaluate the project in terms of real cash flows and real discount rates, and money cash flows and money discount rates. So this is the real cash flows and real discount rates. So this is how it has been explained. So let's see how we're going to have actually what it's been asking us. It's just asking to have the explanation in terms of the real cash flows and real discount rates and money cash flows and money discount rates. So how are we going to actually solve out the problem, which is actually very easy not to actually let's see, it's been discount rate is what, 15.5%. Inflation expectation, when we're going to account for the inflation, which is 5%, given inflation is 5%, the real discount rate is what, R, and its real discount rate R is given by. Let's see how we're going to calculate it. The real discount rate, 1 plus R is equal to 1 plus I 1 plus H. 1 plus R is equal to 1 plus 0.155, and that would be plus 1.005, and that would be equal to 1.10. So therefore R is 0.10 or 10%. Okay, so this is the real rate. Now we're going to apply it like this. Timing, cash flow, PV factor, and PV. This would be 0, 1, 2, 3. That would be 10%, and that would be 7, 50, 330, 242, and 532. So that would be 1.000, 0.909, 0.826, 0.761. That would be 750, 300, 200, and 400, and that would be 150. NPV is 150 with the help of the real discount rate, and that is calculated, and we have also the cash flows in front of us. So this is how you're going to have the PV factor multiplied. You're going to have the PV, and this is the cash flow and the timing. We're going to calculate the NPV. Real cash flows and real discount rates. This is how you're going to calculate. Now we're going to calculate the money cash flows and money discount rates. Of actually money discount rates and money cash flows. So I believe I have actually money cash flows and discount rates. Discount rate as per question is 15.5%, and is the money discount rate. 15.5% is the money discount rate, and to convert real cash, obviously we have to convert the real cash into the money flows. Okay, we have to take into account the inflation factor, which is 5%, starting from year 0 up till 3. So the timing would be the real cash flow, inflation factor, and money cash flow. So this is discount factor at 15.5%. This is PV. Okay, so this is 0, 1, 2 and 3. This is how you're going to do it with the real cash flow: 750, 330, 242 and 532. Inflation factor, which is 1 over here, just adding 1.05, 1 plus 0.05 into 2, and 1 plus 0.05 multiplied by 3, so that whole power 3. So the money discount factor cash flows at 15, and just adding, which you know that multiplying money cash flows, we just have to multiply this into this: 346.5, 266.8, 615.9. Discount factor at 15.50, we have the values 1000, 1866, 0.750, 0.6649. And just to give you an idea that how we have actually reached it, it is 1 divided by 1 into 1.55. Sorry, 1.55. This is how you actually discount it. Just 1.15, that would be 0.866, and 1 into 1.155 squared, that would be 0.750. And here it is 1 divided by 1 into 555 over cube into 0.649. So this is how you're going to say that these values have been extracted. So what would be our present value? That would be 750, 300, 200, 400, that would be 150. Again, that is NPV, and this NPV is in front of you. This is the NPV. Okay, so this 150 is also equal. So this is how we're going to calculate. This is money cash flow and money discount rates. This is how you're going to apply the same the concept, which is the inflation factor, the cash flows, to both to the real cash flows and to the money cash flows. So I hope that I have explained the NPV concept in detail with the help of these two numericals. If you have any confusion, you can actually let me know. We can actually discuss in the comment section or with the help of another separate video. Till the next video with the next problem or the next solution, take care and have a nice day.